One approach to developing a high-temperature resource recovery method to process difficult-to-handle, low-value, bulk waste materials, utilizes a system that harnesses four main working fluid circuits. We wish to explore one of those four arteries in greater detail. We would like to focus on the CO2 pipeline. The Recovery 2.0 system is an innovative approach to manage the treatment of residual waste materials in a sustainable method, by treating waste as a resource, while assisting with the world's demand for clean water and clean energy by using thermal reduction. Within the Recovery 2.0 process, we have focused a great deal of effort on energy recovery, in an effort to manage the energy continuum while attempting to maintain a balance or equilibrium with our environment. One of the key fundamental components in managing waste decomposition is the handling of CO2. Carbon dioxide has some amazing physical, chemical and thermal properties. We would like to outline some of the methods we use to exploit these properties. So, in no particular order or sequence, let's travel through the CO2 pipeline. If we first enter the pipeline, at the point where dilute CO2 is captured from sources such as direct air capture devices or flue gas exhaust. The dilute CO2 is accumulated into an absorption column and may be released as concentrated CO2 into the pipeline. One treatment path for the concentrated CO2 is in a hot carbon reduction reactor, which converts the CO2 into carbon monoxide, or CO. The carbon monoxide may be mixed with steam, in a steam cracking process known as a water-gas shift reaction. This reaction releases hydrogen and returns the carbon monoxide back into CO2. Carbon monoxide may also be used as a reactant in the metal refining process, and may be used in the direct reduction of iron oxide into iron. An alternative path to treating concentrated carbon dioxide is to blend the CO2 with hydrogen, in a methane synthesis reaction, to form CH4. The CH4 may be transformed in a methane pyrolysis process and converted into solid carbon and hydrogen. Oxy-combustion of solid recovered carbon releases heat energy and produces carbon dioxide, which is confined in the CO2 pipeline. At this point the CO2 is a high-temperature, high-pressure gas. The contained high-temperature, high-pressure CO2 may be harnessed to drive a turbine to extract energy, that may be used to generate electricity. The heat in the hot exhausted CO2 may be used to convert water into steam. The exhaust CO2 is collected in a buffer storage well that includes an expandable bladder energy harvesting system. The accumulated CO2 feeds the compressor system. Rapidly compressing CO2 generates intense heat, and this acts like a pumped heat energy system. A heat exchanger may be used to quickly cool the compressed CO2, and the heat is deposited into a hot bank for use at a later time. Once the heat is extracted, the compressed CO2 may follow one of two typical pathways, either as a compressed gas or as liquid CO2. If the CO2 is stored as a compressed gas, it may be blended into the combustion process to boost the oxy-combustion energy output of CH4. The combustion of methane produces CO2 plus H2O. The carbon dioxide and water may be separated or converted directly in an autothermal reforming reactor. If the compressed CO2 is stored in a liquid state, it may be stored at ambient temperature under high pressure. When stored as a liquid, carbon dioxide has a gas-to-liquid compression ratio of 535 times. The rapid expansion of liquid CO2 creates an extreme expansion cooling effect, that may be harnessed to rapidly condense steam in a steam condensing engine. The release of compressed gas or liquid CO2 creates an expansion pressure that may be directed through a turbine for the generation of electricity. CO2 is a versatile and robust material that lends itself to the rapid and repetitive short-cycle regeneration. We hope that your journey through the CO2 pipeline has been informative, and that it may assist you in gaining a better understanding of the Recovery 2.0 concept. We intend to discuss additional facets of the energy and resource recovery sector at some point in the future. Until then, please feel free to contact us at your convenience. Recovery 2.0 is a project developed by Waste.net, in an effort to reinforce our belief that as rational human beings, we must accept the ultimate responsibility to leave future generations with a safe and sound environment, and a world that has not been depleted of its resources. Please feel free to visit us today at www.waste.net.